Hi everyone, Mr. Mark here. In today's video, I'm going to show you how to calculate the coefficient of determination, or that R squared value, and how to interpret that value in the context of this problem, but it'll be pretty similar in terms of making that interpretation or connection between your response and explanatory variables, depending on what they are in your question. First of all, interpreting the coefficient of determination says if there is a causal relationship between two sets of numerical variables, then the R squared value indicates the degree to which change in the explanatory variable or the X variable, or to use scientific language, the independent variable, explains change in the response variable, or the Y variable, or again, to use scientific language, the dependent variable. So let's look at this example here, example 4. At a father-son camp, the heights of the fathers and their sons were measured. So the father's height here is my X, or explanatory variable, and the son's height here is the Y, or response variable. So you can see that they paired these up so that the first father was measured, he was 175 centimeters tall, and his son was measured and he was 167 centimeters tall, and so on. So there were 11 pairs of fathers and sons that were measured. What we're going to do to draw the scatter plot is use our graphics calculator. So in the stats function of our graphics calculator, we're going to go ahead and input in list 1 our explanatory or X variables, and in list 2 we're going to go ahead and list our response or Y variables. Okay, it's important to get that the right way around, and I'll show you basically why. Because the default setting to draw our graph, our scatter plot, press F1 just to make sure that settings are set to how we want them to be. This is the default setting, so your graph type should come up as a scatter plot. If not, obviously set that to a scatter plot by pressing the correct button down here, so F1. And the X variable should be in list 1. Again, if it's not, you can change that. We are setting it as list 1. Okay, so we'll leave that as is. And the Y variable should be in list 2 for this. Again, if it's not, you can change that and set that to list 2. Then we can go ahead and exit and draw that graph. So graph 1, which we just looked at, set as a scatter plot. So there are those 11 points representing along the X-axis, the height of the father, and across the Y-axis, the height of his son. Okay, so now to calculate R squared, you need to go into calculate F1, X, F2, and AX plus B, F1 again, comes up with this screen which gives us a few values. The ones that we're more interested in here are the R value. So R is equal to 0.826. Now remember, in my previous video I spoke about the value of R, or Pearson's correlation coefficient. So a value of R of 0.826 puts it in that moderate positive correlation category. It's almost a strong positive correlation between those two variables, which suggests that there is a causal relationship between the height of a father and the height of his son. Okay, so there is some connection, relationship, correlation between how tall the father is and how tall his son would be. Now, we're actually being asked to calculate R squared here for this set of data. So R squared is equal to approximately 0.683. So I'm going to go ahead and write that down. R squared equals 0.683. Now we usually write this coefficient of determination as a percentage. So I'm going to convert that to a percentage by multiplying by 100, which gives me 68.3%. Now to interpret that in the context of this problem, to put it simply, 68.3% of the son's height is determined by the height of his father. Okay, so this R squared value will tell you what percentage of the response variable is determined by that explanatory variable. Okay, what percentage of the Y variable is determined by that change in the X variable. Okay, so there's still, if you're looking at over 100%, there's still 31.7% of reason, I guess, missing. What are the other 31.7% of reasons that impact or determine the height of that that father's son. There are obviously that are taken into consideration here that we don't really need to talk about, but for the sake of this, things like the mother's height might also come into play. Nutrition, for example, health. So making sure that child is healthy, doesn't have any diseases, things like that. So these are all things that might impact the height of a son. But the main causal factor here, 68.3% of the height is determined by the father's height. Okay, and that's how we interpret two sets of numerical data that have a causal relationship using that R² value. So hopefully that helps. And again, you will obviously have different questions or different examples. It might be the height of the age of a tree as your explanatory variable, and the height of a tree. Again, the R² value will tell you what percentage of the height of the tree is impacted by the age of that tree. Again, just another example. The same thing will happen even if there is a negative correlation between those two values. So if R is a negative value, the R² value will still be a positive value, and that percentage is obviously what we're looking at in terms of interpreting that data. So anyway, hopefully that helps. I'll stop talking now. Thanks for watching.